Jai Hind to all. I, Chelsi Sen, Assistant Professor in the IT Department at AKGEC Ghaziabad. To students, we are going to discuss about the topic Introduction to Cryptography. As you all know that the cryptography is a very essential topic which is used in the security purpose. Today we are going to discuss about the contents: introduction, what is cryptography, encryption and decryption, key, block cipher, encryption and decryption techniques, purpose, types, and we are going to discuss about the digital signature and the RSA. First of all, introduction. As you all know that the internet is a global network which is a connected network of the various applications having in the security reasons. As you all know that we are going to discuss all the applications we used to do in the security purpose. As we do all the communications, all the transaction online through the internet. So very essential topic is, in that case, is the cryptography. So cryptography is an essential topic which is used in the secure communication. So we are going to discuss about the cryptography. So first, let's discuss what is the cryptography is. Cryptography is derived from the word cryptos, which means hidden secrets. So hidden secrets, it's like that ki whatever communication we are doing, that should be kept as a secret. So it is the practice and the study of hiding the information. As you all know that we are doing any transaction, any message communication, or all the data we are transferring from one place to the another place over the internet. So whatever text or whatever data we are transferring, that should be kept very confidential. So cryptography provides us the confidentiality, integrity and accuracy. It is the art in which the plain text is converted into the unreadable formatted, so that the any individual who can access the data can't easily access the data. It is a process in which we convert the data into the unreadable format and again retransmit the data or message into its original format. So cryptography is basically essential for providing us the confidentiality, integrity and the accuracy. So why we use as the cryptography? What is the purpose of the cryptography actually? The purpose of the cryptography is to provide authentication, confidentiality, integrity and non-repudiation. Authentication. What is authentication is? It is basically used, wait a minute, it is basically used in the purpose of authorization. For example, we are providing any accessibility to any person, that is called as the authorization. To authorize particular person, that whether the person is accessing the data, is validating or not, is the authentication. So what is authentication is that proving one's identity. Whatever permission we are giving to any particular person to prove as it is a particular person who is accessing the data or not is your authentication. We are authenticate a particular person for the identification. As you all know that it is a very good example that whenever we receive a parcel, then we receive an OTP. So why we receive an OTP? That is for the authentication purpose, that whether this particular person is taking the parcel or not. So that is the case for your authentication. So this is the particular purpose of the cryptography, to provide the authentication. Means it provides the data to the particular person who is going to access the particular data. Next, it provides us the privacy and the confidentiality. What is privacy and what is confidentiality? Whatever data we are using online, we are uploading on the like for example, we are uploading any information on the online Google Forms, any application on any websites. So that should be kept as a confidential data. Means that should be our confidential data, that should not be accessed by any person. To provide the privacy and the confidentiality, we use as the cryptography. It is an advantage to use the cryptography so that no one unauthorized person can access the particular data. So it ensures that no one can read the message except the intended receiver. Means whoever we want to send the data, for example, I am a sender and I'm just going to send the data to the particular receiver. So only that particular receiver or intended receiver can receive that particular information or the message. For that purpose, we are going to use the cryptography. Next is integrity. Cryptography ensures that the integrity should be maintained. For example, we are sending the information to the particular receiver. Whatever information we are sending, that particular information should be sent to the receiver. No other person can access that data or alter that data in the original format. For example, it assures that the receiver receives that message whatever I sent. So it assures that the whatever the data I am sending, whatever information I am sending, that should be original, not to be altered in between. So it maintains the integrity. Next is non-repudiation. What is non-repudiation? Non-repudiation determines that whatever data I have sent is really sent by me or not. It authenticates the particular person that he or she cannot deny that it is sent by the particular person, or it is followed for the vice versa case for the receiver also. So it is followed for the sender also and the receiver also. So in this mechanism, it proves that the sender really sent the data. You can't deny the truth that whether you have sent the message or not. Next, these are the basic terminology we are going to discuss in the cryptography. Whatever process we are going to apply, these all terminology will be used in this particular process. What are the terminologies? First one is plain text or the clear text. It is denoted by P or M. Means whatever information we are sending, whatever message, whatever data we are sending, that is called as your plain text. Means any information we are sending, for example, we are sending any message. So we are denoting it as a M or P. Next terminology is encryption or encipher. What do you mean by encryption? Encryption means we told that the cryptography, in that we convert the plain text into the cipher text or encryption text. So there we will be applying the encryption, and that will be denoted by your E. Okay, so encryption will be denoted by E. It is the process in which we are going to apply various algorithms in the encryption. Next is ciphertext. What is ciphertext? Whatever plain text we are going to convert, that is going to convert it into the ciphertext. Means it is the plain text which we are going to convert into the unreadable format. That is called as your ciphertext. Again, the process is decryption. What is decryption? The process in which whatever process we convert ciphertext into the plain message. Again, we are converting our ciphertext into the plain message. That is called as the decryption. So what was the overall process? We are converting a message by applying encryption and decryption through a message. Means we are converting our plain text into the unreadable format, that is the ciphertext, and then again we are converting into the original format, that in which we have sent the data. Okay, these are the basic terminology which will be used in your cryptography overall process, in which we are going to apply various algorithms. So let's discuss what is encryption and decryption. In cryptography, we use two processes, encryption and decryption. We have discussed earlier also that the process of converting the plain text into the unintelligible format. Unintelligible format means unreadable format, or it is a secured format. Okay, in which what we are doing, message is converted into the ciphertext, and ciphertext is what is unreadable format. So what is this process? This process is called as your encryption, in which we are converting our plain text into the ciphertext. Again, it is the vice versa case for the decryption. We are converting the ciphertext into the plain text. This is called as your decryption process. So we are converting ciphertext into the, again our message is called as the decryption. So these are the terminology which we are going to discuss in the cryptography. In cryptography, we use two terms, that is key and the block cipher. Key and the block cipher is used in the process of encryption. Encryption and decryption is used on the key based. We are doing the encryption and decryption according to the basis of key. Key is a type of like a variable value which we can apply through an algorithm, or a string or a block in encrypted text. Like what we are doing, as we all know that we use different type of pens, password. So that is the case for your key. Means we are using a variable value or a string or a particular block in which we are applying some algorithms to produce the unencrypted text. So that what we are doing, we are converting our particular value into the particular text, and again what we are doing, we are decrypting the particular unencrypted text into the particular value. So these will be going to use in your key. Key is used for the encryption and the decryption, and in that key we are applying various algorithms like the RSA algorithm, DES algorithm, various algorithms we are applying to generate the particular key for the encryption process also and the decryption process also. Next terminology is that block cipher. What is block cipher? It is the method of encrypting and decrypting the data key used for the encryption decryption. Means whatever input we are sending to the receiver, that size should be same for the input also and the output also. Means the message output at the sender side and the receiver side, both the size should be same. For example, we are converting 16 block, this is the 16-bit size of our data. Okay, we are converting into the 8 block. Okay, so the amount at the sender level and the receiver level should be same. Okay, so the size of the data should be at the input, at the output should be same. Next is key based encryption and decryption. Means we have discussed about that key, that we are going to use the key for the encryption and decryption. So according to that only we are having the two cases. If our key K1 and K2, both the keys are same, means both the key are same, then the case of the symmetric. Means if both the keys are same and they can derive from each other, then that is the case for the symmetric case. Means we are using a encryption and decryption from the same case. Means we are encrypting our data into K1 and we are similarly decrypting that data from K2. So that is the case for your symmetric case. Next one is asymmetric, in which we are using the different keys. Means our K1 is different and K2 is different. They are not equal. So that is the case for your asymmetric cryptography case. Okay, so this will be used in the encryption and the decryption, in which if the keys are same, then this is the symmetric. If the keys are different, then it is asymmetric case. According to that only, we are dividing the cryptography into two types. That is the symmetric and asymmetric also, and we call that is the case as a secret key cryptography. It is the case for the symmetric, in which we are using only single key. Single key means we are using K1 for the encryption also and the decryption also. Means only one key we are using, for the encryption and the decryption, and these keys should be known to both the parties. Which both the parties means who is sending the data and who is receiving the data. Okay, both sender and receiver will be using the same key. Sender will also use K1 and receiver will also use K1. Okay, so this is the case for the secret key cryptography. Why we are calling as a secret key cryptography? Because we are using only one key for the encryption and the decryption. What are the advantages? We are using only same key, so it will be so simple and the faster. Whatever the process will be there, that will be very faster. But one of the disadvantages is that it is the less secured, because if in case it is loosed or it can be accessed by any person. So who the particular person can access the particular data. Again, we just discuss about the various advantages, disadvantages, and the example of the secret key cryptography. Secret key cryptography can be called as the symmetric, or we can call as a single key cryptography algorithms. Both the encryption and decryption key are at the same, means we will be using the same key for the encryption and the decryption. We will be using the particular method, like the substitution method we can use for that, and the permutation method. These are used in the mathematics also. So we are particularly substituting particular value for the encryption purpose. These are based upon the stream ciphers. Means stream cipher means whatever value we are transferring, which will be based upon your bit or a byte. Means you are transferring the data into the bits or the byte. Similarly, we have discussed about the block ciphers. It going to operate on the blocks, means 64 bits data will be used in the particular information. What are the advantages for the secret key cryptography? It is simple and the fast. Disadvantage is that in the particular key exchange, sometimes the key can be exchanged or key management is loose. Then this is the disadvantages for this particular process. So in that case, it will be less secured. There are the various examples or various algorithms used in the secret key cryptographies: DES, RC4, IDEA, Blowfish, and AES. These are the various algorithms which we are used in the secret key cryptography. Next is asymmetric key cryptography. As you know that in asymmetric key cryptography, we are using the two different keys in which the K1 is not equals to K2. Means both the keys are different. And that's why we call as a public key cryptography, in which we are using, for example, if we are using it is a public key, then it should be a private key. Okay, so we are using two different keys for the encryption and the decryption. So that's why it is more secure, because we are using two keys for the encryption and the decryption. Similarly, it's more advantageous for the authentication purpose. How we can authenticate? Because we are using a particular private key for the particular sender. Okay, so that's why it is more authenticate and the most authorized. The disadvantages of the asymmetric key cryptography is relatively complex than the asymmetric cryptography. Okay, next is public key cryptography. Similarly as your asymmetric cryptography, in which we are using the public key and the private key. As you know that the private key is a secret key in which we can't share the private key to the everyone, and the public key is known to the every person, every receiver. It can be known, or the sender, it will be known by both the sender also and the receiver also. But in the case of the private key, only sender will know about the particular private key, and that should be kept as a secret. That's why it is more secured. So asymmetric cryptography, as we know that we called as a public key public key cryptography, it is used on the basis of public key cryptography. Similarly, encryption and the decryption keys are different. If we are using encryption for the private key, then we are using the public key for the decryption. We have to use the vice versa case for the things. For example, if we are using public key for the encryption, then what we have to use? You have to use private key for the decryption. For example, I can show you through the example. You have sending the message. Here it is a sender and it is a receiver. So particularly sender is sending the information through the encryption process, right? So if the sender is using private key for the converting the message into the ciphertext, Then what the receiver will use the decryption process, and decryption will be done by using the public key. Why? Because we had used here the private key, so we will be using, at the time of receiving, we will be using the public key. Vice versa case can be followed. If we are using the public key, then we are going to use here as a private key. Okay. Now similarly, just discuss about the advantages. Advantages is the better key management. Here we are having a better key management. We are using two different keys. What is the disadvantage? It is little complex, so that's why it becomes very slower. So both the techniques are complementary. In this, we are going to use the RSA algorithm, Diffie-Hellman or AI-Gamma. These are the algorithms which are used under your asymmetric cryptography. So private keys are used for decrypting and public keys are used for encrypting, and this is the process which we are using in the cryptography. This is the overall process for the cryptography. What we are doing, plain text is converted into the ciphertext, means whatever message, whatever information which is going to convert it into the unreadable format. Okay, same thing we are doing for the ciphertext. We are converting whatever unreadable data which is going to convert into the plain text, which are used by the decryption. So encryption is using a public key and decryption is using as a private key. At last, we just summarize the thing, what are the different types and what were the things we are going to discuss. These were the three types. That was the secret key, symmetric, asymmetric and the hash function. In symmetric key, we was using only single key, both the keys are same. In the asymmetric cryptography, two different keys are used, this is different and this is different. Okay, so this is the asymmetric. Asymmetric we call as a public key and symmetric we call as a secret key or a private key. Last one is hash function, in which we are transferring our plain text into the ciphertext using some function, that is hash function, or you can use some hash values. It is also very useful for the authentication purpose. So in this, we are not using any key. We are just transferring our data into plain text into the ciphertext, which is not recoverable. For example, once we have converted our plain text into the ciphertext, so we can't convert the ciphertext into the plain text. Using the hash value only, we can convert the particular values. Next, we are going to discuss about the digital signature. It is an application of your asymmetric cryptography. In this, we are going to, it is used for the authentication purpose. As you all know that everything is done at any document you upload on the websites, which should be authenticated, which should be authorized by the particular person. So we are using the digital signature for that purpose. So public key encryption ideally is suited for the digital signature. It is a reverse of public key encryption and decryption. For example, to sign a message, you use your private key to encrypt the message. Means whatever message you are sending, what you are doing, you are generating a particular message to authorize your particular message, that whether this message sent by you or not. Okay, send this signature together with the message, means whatever information you are sending, whatever message, whatever communication you are doing, along with that you can send the data or send the signature, so that you can authenticate to the next person also and to you also, that this particular information is sent by you. It is used for the non-repudiation case. As we have discussed already that what is the non-repudiation, in which that the sender or the receiver cannot deny that this particular message or the information is sent by he or she. So he or she cannot deny this information was sent by this. Or similarly case for the receiver, that the receiver cannot deny that whether he or she can have received the particular message or not. So for the authentication and for the truth purpose, you are using the digital signature. Only you could have signed the message since your private key belongs to you and you only. Means what you are doing for generating a particular sign, what you are using? Private key. Private key is used for the generation of your sign, so that you can authenticate to the particular person that no one have received your data, no one can alter your data. The receiver saves the message and the signature, and anyone else can verify that you should verify that you have claimed it or you have claimed the particular thing. This is the overall process for the digital signature. What was you are doing? This is the message you are going to send to the receiver. This is the sender and you are going to send to the recipient. Okay. So what you are doing, whatever message you want to send, along with that you are generating one sign. So this is the process for your signature generation. Means what you are doing, you are generating one sign for the authentication. So how you are going to generate the sign? You are using some hash function or the private key so that you can generate the particular sign. So what you are sending? Message you can encrypt or decrypt by using the encryption technique. Along with that, what you are sending? Signature, and it will be received by the receiver. So what receiver will do? Here in the particular receiver will be verify the particular sign. Okay, so this will be verified by the particular receiver. What you are doing? Message will be converted, again the hash value will be converted. Okay, then this will be calculated whether this function is same or not, and it will be generated, it will be verified by the public key. Means you are generating the particular signature through the private key and you are verifying it by the public key. So this is the overall process for the digital signature process, that you are sending the message, along with that the signature is generated through the private key and receiver is receiving the particular message, and he is converting the particular value into the hash function and again verifying the particular value through the public key. Thank you.